In this video, we're going to talk about the coefficient of determination. This is very strongly related to the correlation coefficient, but it is a little different. So let's talk about the coefficient of determination. Now here, I've shown you this graph already. I showed this to you in another video about correlation itself. And we could see high negative correlations, moderate negative correlations, little to no correlation, moderate positive correlations, and high positive correlations. Again, the high, moderate, and low is how close is your data to the line. The closer that the data follows that line, the higher the correlation is. And then whether it's positive or negative determines whether you're going to have a positive slope or a negative slope. But what might cause an increase in the variance? What might cause the data to be more spread out around that line? Well, simple answer, other variables. Lurking or confounding variables can always get their way into a statistics problem. But even if you've accounted for them and they're not lurking variables anymore, that doesn't necessarily mean that two variables that you're looking at will be purely correlated. Yeah, that's right. The other variables that you've accounted for might also be having an influence there. So how do we judge how much of our data has been affected by the explanatory variable? Well, we learned about the correlation coefficient. That's the value R. R squared, just taking R and literally squaring it, is known as the coefficient of determination. We're going to determine how much the response variable is influenced by the explanatory variable, right? So R squared is going to be a percentage. Now, the way that we would read the coefficient of determination is saying that R squared as a percentage of the variation in your Y variable can be explained by the X variable. All right. So in the example that we have been working on, we might say something like, I've got it right here. Perfect. We saw in our last couple of videos that the correlation between height and weight is 0.923. So what's the coefficient of determination for our height and weight data set? Well, seriously, just square the correlation coefficient. That's all you need to do. 0.923 squared is going to be 0.852. That means 85.2%, right? To go from a decimal to a percentage, just multiply by 100. So what does this number mean? Well, here's how I would interpret it. 85.2% of the variation in the subject's weight, that's my Y variable, can be explained by the subject's height. That's my X variable, right? Hence why the X variable is called an explanatory variable. The subject's weight can be explained by the subject's height. How much of that variation is explained by the height? 85.2%. The other 14.8%, that's caused by other variables, the confounding or lurking variables that we have had to deal with. Now be very, very careful. It is very easy to think in this way. 85.2% of the variation in the subject's weights is caused by the subject's height. It's very easy to say that we found a relationship, therefore the explanatory variable is what causes the response variable. The height causes the weight. That's not true. All we've shown is that they are related. There could be a causal relationship, but we don't know. Having two correlated variables does not guarantee their relationship is causal. even if there is an association identified between the two, even if we know there's a relationship between the two variables, we cannot say that the explanatory variable causes the response variable. All we can say is that the y variable is the variation in the y variable is explained by the explanatory variable. So in this particular example, does an increase in height cause an increase in weight? We can't really say that for sure. Science indicates that yes, it does, but that's science. That's another field. All that we can say in statistics is we have seen that if there's an increase in height, there is also an increase in weight. And 85.2% of the variation in all these different people's weights can be seen in the variation of their heights as well. So there you go. How do we find the coefficient of determination? Just take the correlation coefficient and square it. That's all you need to do. And then you take the coefficient of determination, turn it into a percentage, and that's how much of the variation in your response variable that you can attribute to or explain with your explanatory variable.